This video is going to look at using the distributive property to help you solve equations. And one of the first things we're going to look at are a couple examples of situations where you could write an equation that would involve the distributive property. So here, this is taken directly from your textbook or your workbook. Example 1, we've got a case of graphic novels in Chen's collection, and they've all increased in value by $3.50 in the last few years. And we're told that each graphic novel has the same value. So that means they also had the same value at the start. And what we're trying to find out is the original value of one graphic novel. So here we can use whatever variable we want for to represent the value or the price of the original graphic novel. But we're told a couple of helpful things over here. We're told that the total value is 75. So if you remember, we said that once we know a total amount, that is cluing me in really to what's going to be on one side of my equation. So I know that whatever other expression I come up with is going to equal 75. And while here, I'm told he has 10 graphic novels. But if I look back at the text, I'm told that they've all gone up. Every single one of these 10 has gone up by $3.50. So if I'm just looking at the expression for one book, right? Well, the expression of the value of only one book would be G, because that's the letter I chose to use, or the original value of the graphic novel, plus $3.50. Because they started at a price, and then we're told that it increased by $3.50. So this represents one graphic novel. But this happened for every single one of these, right? So how would I show that 10 graphic novels all have this value right here of G plus 350? Well, that's where my distributive property comes into play. Because what I would do is I can write 10 outside a set of parentheses, and this says that this is the value of one book, as we talked about, but we've actually got 10 of them that had the exact same situation. So here's my my equation. Now what we do for solving this, there's kind of two ways we could go about this. The simplest is, what is the operation going on between the 10 and the thing inside the parentheses? Well, we know that what's going on here is multiplication. So my first step, so step 1 is I'm going to do the inverse of multiplication. So instead of multiplying 10 to each of these terms inside, which is what I would do with the distributive property, is I can actually just divide both sides by 10. So step 1, I'm going to divide by 10. And what we see happen here is when I divide this by 10, what actually happens is that this cancels out, right? We said that becomes 1, which doesn't really change the value of anything. And then I also, like we said with this golden rule of equations, I have to do to both sides. So 75 divided by 10 becomes 7.5. So now what I've got is 7.5 equals G plus $3.50. Okay? And so now it's a matter of, well, how do I get this G by itself? I need to subtract 350 from both sides. I'm doing the inverse operation of adding 350, so I'm subtracting 350. So whatever I'm left with, since G doesn't have a coefficient greater than 1, or it's just G, whatever I get when I subtract 7.5 and 3.5 is my value. And so I find that each one of these comics is actually going to cost $4. Okay. Now, the other way I could have done this, if I look back at my original, let me scroll down a little bit. If I reimagine this, so let's put a line here to separate them. If I reimagine this, I could go 75, so this is what we got to, right? We got 75 was equal to 10 times G plus $3.50. What I could do is I could do the distributive property. There's the bell for the end of the day. I could do that distributive property. So this would become 10 times G is 10G. This becomes 3.5 times 10 becomes 35. And then from here, now, this looks familiar. Right? This looks like what we've been doing. And actually is pretty much what we had happen in the one above as well. Okay, so then I can subtract 35, and I get 40 equals 10G. And then lastly, I would divide by 10. And notice I get the exact same answer. I find that each one costs $4. Just two different ways. So the first way, what I did was I divided both sides by 10, because 10 is what was going to be multiplied.
Heath Becker, call the office. Heath Becker, call the office.
It's a noisy time of the day. Was going to be multiplied by everything inside, so I just divided that right away. The other way was to actually do the distributive property, and then I realized, oh, this looks like the types of problems we've been working with already. Okay, so let's look at one other example here, and here's one where, well, let's save that one actually. Let's do this one here. So here, this is going to be a similar thing. We need to write the equation. So we have a cheerleading squad received 1/4 of the total sales of the foam fingers and pom-poms at a pep rally. They received a total of $136.75. So that's the total amount. So I know that's going to be on one side of my equation. It could be the right or the left. Doesn't matter. And then we've got we know that we received, we received $258 in foam fingers. So $258 is the total that was made, I should say, not what the cheerleaders received. And then what happens is we know we get 1/4 of this, and we also get 1/4 of the amount of pom-pom sales. So if I add those amounts together and multiply them by 1/4, that's going to be my equation that we have here. Another way sometimes it's might make more sense to you to not think of it as a distributive property. So you could have also come up with an equation that would look very similar. It'd actually maybe save you a step in the long run. Is maybe you recognize, okay, this $258, I only get 1/4 of that. So maybe what you do right away is you take 1/4 times 258, and then you also know that, well, I'm going to get 1/4 of the total sales of the pom-poms. Okay? And so maybe your expression looks kind of like this, which if you realize, this is just like what my equation over here is saying. It's just saying that 1/4 gets multiplied by both of these numbers. Okay? And we see that that's the case. So 258 divided by 4, that's the same as multiplying by, is 64.5. So we get $64.5 here, $64.50 plus 1/4 P equals 136.75. And then I can solve for my equation. Right? And we talked about before how some of you asked me yesterday, well, 1/4 P, that's really the same thing as saying P divided by 4. So this maybe is a helpful way to think of that. And again, I could solve this. One thing I could do is the shortcut maybe is to divide both sides. If I'm looking at this, so I'm going to just kind of put this one in red, and I'm going to ignore it for the time being. That is another way I could solve that. Looking at what we did before, once I have this equation, there's two ways I can do it. I could either distribute this 1/4 to both terms and then go ahead and solve. If I did that, I'd get to this part right here, and I could just find my variable. Or, like we said, the other shortcut is I could do the opposite of multiplying by this number. So it means I could divide both sides by this. So 1/4 divided by 1/4, that becomes 1. So I'm left with really just 258 plus P. And then 136.75 divided by 1/4 is the same thing as 136.75 multiplied by 4. Okay, because when I divide by a fraction, I just invert and multiply. So this really becomes the same thing as multiplying by 4 over 1. So I look, what is, there's my calculator again, 136.75 multiplied by 4 is $547. Okay. So this means, right, or not, this isn't my final answer, 547 is equal to 258 plus P. And then my last step is now I need to get the variable by itself, so I'm going to do the inverse of adding 258, and I'm going to subtract 258 from both sides. So I end up with P is equal to 547 minus 258. I should have just left my calculator up. Let me do this. 547 minus 258 is equal to $289. This means that they sold $289 worth of pom-poms. Okay? All right, and so there's how we would use a distributive property. We looked at how we would write an equation that involves a distributive property. And we also looked at how we would solve an equation using distributive property.